This 2020 paper 2 question 9, we have to find the distance between these two ships 30 minutes after they set sail. So after 30 minutes, they will have traveled half of this distance in kilometers per hour, because 30 minutes is half of an hour. So if they do 15 kilometers in an hour, well, that means it'll do 77.5 kilometers in half an hour. So I suppose what we can think is what the new kind of thing, we'll have A here, we'll have a point here, and this distance now, it'll be 90 minus 7.5, so it'll be 82.5. And then in terms of B, it will have moved over to here, and it will have moved down by 15 kilometers, because that's half of 30. It does 30 kilometers in an hour, so it does 15 kilometers in half an hour. You can just use a distance speed time equation if you want, if you're not able to do it in your head like that. So that means it will have moved down by 15, so B is here. So to find the distance between them, we just need to find this hypotenuse. This is a right angle triangle. I think they say, yeah, so we have east and south, so that's going to be a right angle. So we can call this D for distance. So we can say that D squared will be equal to 82.5 squared plus 15 squared. So D will just be the square root of that. So square root of 82.5 squared plus 15 squared, and you can just throw that into your calculator. And you should get 83.85 kilometers as your answer. Then we're told to show that this is the distance between the two ships at any time. So we basically need to generalize this. So we start at 90 kilometers, and let's figure out how far it travels. So instead of after 30 minutes here, this is just after t hours. So t is in hours. So for ship A, speed is equal to distance divided by time. So the distance it travels will be the speed, which is 15, multiplied by time, which is t. And then for B, we have the same thing. The distance will be equal to the speed, which is 30, multiplied by the time, which is t. So if we now draw out our triangle as we had up here, we had the 90 and then we had the straight line. So if we have A here, and this distance here, it's going to be 90, right? Yeah, it's going to be 90. Then we're going to take away however far A travels. So for example, when A is moving this way, so as it moves, the distance that it covers is subtracted from this 90, because this 90 gets smaller. So it'll be 90 minus 15t for that reason. And then this side here, well, it starts at a distance of 0, and then it's going to keep getting longer, this distance. So this distance will be 30 times t, because that's the distance traveled by B. And then to find the distance between the two ships, we just find the hypotenuse. And we can call that, well, it's a function s of t. So s of t squared. Now you can just write s, it doesn't really matter. It'll be 90 minus 15t, the whole thing squared, plus 30t, the whole thing squared. So make sure that you square these out properly. So this will be 90 squared minus 2 times 15 times 90. Sorry, that should be 15t. And then we'll have plus 15t squared. So it'll be 15t, the whole thing squared, so it's 15 squared times t squared, and then we have plus 30 squared times t squared. So there are all the terms that you should get, and then you can just simplify. And here you'll get 8,100, and then you'll have minus 2,700, and that's a t term, and then 15 squared is 225, so plus 225 t squared, and then we have plus 900 t squared. So that'll be equal to, so the constant is just 8,100, minus 2,700t, and then we can combine these like terms to be 1,125t squared. And then we just need to square root both sides, or the way they have it in the question is they have the power of a half, and they put the t squared term first, as you can see. So we can say, therefore, s of t will be equal to 1,125t squared minus 2,700t plus 8,100, all to the power of a half, which is what they asked us to do. And it makes sense that t is between 0 and 6, because when t is 6, this will be 90, and 90 minus 90 is going to be 0, and then this distance will be negative. So it makes sense why t is between 0 and 6. Just kind of like, I suppose, gut check your answer in a sense. Then we have to use calculus to find the value of t when the ships are closest together. So we're going to take the derivative and let it be equal to 0. So s prime of t will be equal to, so we have a chain rule, we have an inside function and an outside function, so that we take the derivative of the inside function first, and that'll end up giving you, so for we bring this 2 down here and we multiply, and we'll end up getting 2250t minus 2,700, and then the derivative of this constant is 0. So we take that as the derivative of the inside, multiplied by then the derivative of the outside. We take this a half down, So as down the front is a constant multiple, and then we have the bracket, just like this. I'm just going to copy it down to save time. And then we reduce the power by 1, so we'll have minus to the power of minus a half, and we want to solve this equal to 0. So we can simplify a little bit. So a half can distribute into this kind of, well, actually, we could just multiply the whole equation by 2, because when you multiply this side by 2 and this side by 2, 0 is going to go away. So it ends up just being 2250t minus 2700, and it looks quite messy, but because this is the power of minus a half, you can write it in the denominator as the square root of 1125t squared minus 2700t plus 8100, and if that's equal to 0, well then when we multiply this up, and again you can keep the 2 down here if you want, but we're going to multiply that up and it's not going to make a difference. When we multiply up by this, we're going to end up, it's going to end up, well, when we multiply the left side, the fraction's gone, and we multiply the right side by this, well, it's 0 times something, so it just ends up being 0. So that stuff's all gone. And then we get that 2250t is equal to 2700, which means that t is equal to 2700 divided by 2250, which is equal to 1.2, and the unit is in hours, because t is in hours. But then we also need to find the distance, as the question says, so we can take this function, which is for the distance, and we can just sub in 1.2 for the 1.2 hours. So s of 1.2 will be equal to, it'll be 1125 times 1.2 squared minus 2700 times 1.2 plus 8100, all to the power of a half. And you can just put that into your calculator and you should get 80.5 kilometers when you round it to 1 decimal place, which is what they ask for. So yeah, there we go. That's the question.